Dear student, the experiment number 5 is RC phase shift oscillator. So you know that oscillator means you are providing the positive feedback. There is no AC input. Without AC input, it generates the AC output signal with the help of bias voltage. So the condition for oscillation is Barkhausen criteria. That is A beta it should be greater than 1. Then phase shift is total phase shift is either 0 or 360-degree phase shift. So this is the circuit diagram for RC basic oscillator. So in that, this part is providing amplifier, then your feedback the output to the input. So in this case, this capacitor is the coupling capacitor. This C1, C2, C3 and R1, R2, R3 forms the feedback network. This is the amplifier. This is the feedback network. So in RC phase shift oscillator, the C amplifier provides 180-degree phase shift and this 3 RC network provides 180-degree phase shift. One RC network provides 60-degree. So totally 3 RC networks are there. 3 into 60, 180-degree. So total 180-degree amplifier, 180-degree feedback network. So totally 360-degree phase shift of provider. So this is the simulating diagram using LTspice. Then the output voltage. So here we want to check the output voltage. So this is V out. So this is A. So both are same. This is the coupling capacitor. So here you should measure the output voltage at the point A. The output voltage at the point A. Then you measure at B. There will be 60-degree phase shift. Then with respect to B, C is 60-degree phase shift. Then with respect to C, D is another 60-degree phase shift. So with respect to A and this point, you will get 0-degree phase shift. So you should measure all the instant A after the first pair B, then after the second RC pair, after the third RC pair. So these are the waveforms are given VA, VB, VC. So the zoomed version of this waveform. After that, you should calculate the frequency of the oscillator. So for theoretical frequency calculation, use the formula F naught is equal to 1 by 2 pi RC root 6, where RC is the resistor and capacitor in the feedback network. Resistor and capacitor in the feedback network. So here the feedback network resistor is 5.1 kilo ohm. The capacitor is 0.01 microfarad. So using these two values, you can calculate here R1, R2, R3 alone. The BJT is not infinite input impedance. So parallel combination of this input resistance and you will get R3 is 7.5. Then R1, R2 are 5.1K. Then C1 equal to C2 equal to C3 equal to 0.01 microfarad. Then collector resistor is 15K. Emitter resistor is 3.3K. Then this resistor R4 is 27K. This R5 is 150K. This two are forms the potential divider. Okay. So now we will go to multi-sim window. So now see here. Now see here. So you go to that already you know go to that components. You take all the components and place as it is. You connect the components as per the circuit diagram. After connecting the components, you change the values of all the components and the namings. So this is RE, CE, RC, C word, C2, C3, then that values are 3. Okay, so then VCC is equal to 10 volt. Then you go to that node, name it as either A, okay, then keep it here. Similarly, you name it B, you name it B, C like that, then keep it there. After that, go to simulation, edit simulation command, transient analysis, specify the stop time. I'm given 200 milliseconds, then do OK. So place it here, then run the simulation. Okay, so here either you can check the voltage at all the instant A, B, C, D or like that, or otherwise you can go to right click, add a trace. You can select VA, VB, VC, VD. Okay, then give OK. All the traces are added. So now you want to see the zoomed version of this waveform. So you zoom like this. See here. Now this is the voltage at the point here. That is my output voltage. Then VA and VB with respect to VA and VB. So the phase shift will be there. See here. This is the negative. Here is 60 degree. So further closely you want to see. So run the simulation. Right click, add traces. A, B, OK, and maximum is okay. Now this alone you want to see the phase shift 60 degree. So here then you want to measure the, see here at that particular node you can see. So give zoom out. Now, now you are having the further you want to zoom, or I can now like that you see. Now clearly you can able to measure the time period. So this is the peak and the 1, 2, 3, 4, 5, 6, 7, 8, 9. So the maximum value is here 8.4 to minus 4.8. That peak to peak you can calculate. So totally half of the waveform. See here at this point to this point. So frequency you want to calculate. So calculate the time period, time difference between this and this. Okay. Then you can find out the frequency. Now you can see clearly. So from here to here, this time period. Okay. One cycle you can take. So find out the time period difference. Then calculate the frequency. Then write the frequency and the practical frequency and theoretical frequency more or less closer. Okay. Okay, ma. Thank you. We simulate and submit. Okay.